This is the solution to chapter 16 video assignment 1. The question states, suppose a small bird has a mass of 30 grams. What is the moles of glucose that it must metabolize to fly up to a branch 10 meters off the ground? And it splits up into a few parts. A, the metabolization of glucose is the reaction that reacts glucose with dioxygen gas to produce carbon dioxide and water. Write that balanced equation. B, calculate delta G reaction for the reaction in A. The free Gibbs energy for glucose is negative 917.2 kilojoules per mole, and instructs us to look up the rest on the OpenStax book. And C, the Gibbs energy liberated by the metabolization of glucose provides the energy to lift the bird. The work the bird is doing is working against gravity, that is, work equals mass times acceleration of gravity times height in meters. And lastly, D is use your answer from B to determine how many moles of glucose are needed to complete the action in C, given that the metabolization provides the energy per mole as given in B. So ultimately the question we're trying to solve is how many moles of glucose does it take for this bird to fly 10 meters onto a branch. So for step A, we're just instructed to write the balance equation for glucose. So we have glucose C6H12O6 plus dioxygen O2 is equal to CO2 and water. So just balancing the reaction, first we can balance the carbons here. So we got 6 carbons on the left, we'll get 6 carbons on the right. Next we can balance the hydrogens, so we do that by balancing the water on the right side. So we got 6 hydrogens here, so since we got 2 hydrogens in water, we'll do a coefficient of 6, so that balances the hydrogens. Now from doing this, we've got a surplus of oxygen on this side, so it adds up to 18. 6 times 2 is 12, plus 6 times 1 is 6, 12 plus 6 is 18. So we gotta have 18 on this left side, we got 6 here in glucose, so we'll make this coefficient 6. So that's 12 plus 6 is 18. So our balanced reaction is C6H12O6 plus 6O2 reacts to form 6CO2 and 6H2O. So now it instructs us to solve for the free Gibbs energy released by the metabolization of glucose. So delta G for reaction is the sum of the delta G of the products minus the sum of the free energy of the reactants. So doing that here, just looking up in the book, I've got the free Gibbs energies for CO2 and water multiplied by their coefficients of 6. So 6 times 6 times negative 394.36 kilojoules per mole plus 6 times negative 237.1 kilojoules per mole minus the products, the reactants. It provides the reactant for glucose. We have a coefficient of 1, and for oxygen gas, for the free Gibbs energy of formation, it's just going to be 0 for how that works. So that's just going to be 6 times 0 is 0, obviously, and the whole thing equals out to negative 2,872 kilojoules per mole. Now this is how much energy is liberated by the metabolization of glucose, and we have in kilojoules per mole. So now we need to determine how much work it takes for the bird to fly from the ground up 10 meters. So a little bit of physics. So work is equal to the mass of the bird, it's given in grams, so we just convert it to kilograms right here, times the acceleration of gravity, 9.81 meters per second squared, times the distance, which is 10 meters. So that gives us 2.943 kilogram meters squared per second squared, which is equal to a Newton meter, which is equal to joules. So 2.9 joules is the work required. Now this is the work required, and this is the amount of energy that's liberated. We can just simply multiply those two, well, the inverse of this one. So to determine the moles, right? Because we got kilojoules over mole, and we got joules here. So we'll just take the 1 mole per converted to joules. 2,872,000 joules are released from 1 mole of glucose when it's metabolized, times the number of joules required to perform the action, 2.9, equals 1.0 times 10 to the minus 6 moles of glucose are required to perform for the bird to perform the action of flying 10 meters up to the branch.